This time we are focusing on some good features and good things to know, which is from version 17 and which will be helpful for the engineering part. So that will include engineering of PLC and also the programming or configuring the total PLC program easily. Also includes the versioning of the PLC programs, and finally the simulations. And the most important topic, which nowadays is basically the security part of view, how TI portal is taking care about the security behind this. So, and in between, if you have any question, you can always ask it in the chat box. Our colleagues are already there to answer the questions. Okay, so I'll just keep my highlighter on also. Yes. So TI portal, as you already know, the base was basically, it's not a software, it's a platform which is having connectivity to all the different softwares like STEP7, CMO code, means Sirius for CMO code, CMotion with for Scout and Dynamic Start drives, then safety and WinCC. This was the base. By default it was already there, and on and above of this we also have different other functionalities like energy suite, PLCsim advanced, VCI test suite, TI user management, which is basically both for multi-users or exclusive engineering and software units. Then we have the TI portal cloud connector, Dynamics DCC, TI portal openness, semantic visualization architecture, and TI portal multi-users, 1500S Simulink and Team Center. So all these things you have already seen many times, but many new things are evolving, because TI portal is something like every with every version you will get more features, which is much more making it flexible and usable uh, for customers, OEMs, and also people like you who are mainly working on the system. So all these things are helping you out to do an easy engineering, and also to get the data, as you will see uh, in the coming few days. There will be one session on IT/OT integration. So the app portal is also giving you the flexibility to do the IT/OT integrations with the software packages already available. On above of this, there are other softwares also, which is helping you for the doing the engineering. So in some of them are like Proneta or Semantic Automation Tool, and you know that Semantic Automation Tool is and Proneta are, it is also having a license versions. Then it's for designing your network. You can also use CNET plant, and then other softwares are also there. And apart from that, you get. So there are three divisions. You can see it is already highlighted, like with a open architecture, means work open, virtually network, digital workflow with AI portal. Then you have the reduce your time. So how the engineering time can be reduced with the integrated engineering in AI portal, and the how to have increased productivity with transparent operation with AI portal. So this is like the three different pillars and how the different things are positioned. So for increasing your productivity, the things like semantic OPC UA with S7 1200 uh, is now available. OPC UA alarm online diagnostics and are available, and semantic energy suite, some new features with energy suite. Then which is also because semantic energy suite is already a part of transparent operation. Then we have the user management, because central user management is mostly in case of unified panels, this is must use part. And also we have the prototype. Then today's highlighted topics which we are going to cover in this presentation is basically on the part of security with TIA. Then we have the motion controls will not be covered here, but 1500 RNH. This will have a different session. After this session, there will be another session on 1500 RNH, which including the different safety, because in 1517 we with basically in version 17 we also have the new inclusion of CPU, which is for the safety part. Multi-user with, and also UMAC, multi-user engineering, having every time from version 15.1 onwards, every year multi-user engineering is developing day by day, because in the first phase it was only multi-user engineering, then it came up with software units, then it came up with the exclusive engineering. So all these things were already covered in many other previous slides, but multi-user engineering is now helping out not only do the reduce the engineering time, but also keeping the version control or different versions of the project. Because if you know, in multi-user engineering, normally we have multi-user engineering as a engineering platform for different engineers working in different section of the program. Apart from that, in case of if you are using an exclusive engineering, there is a possibility of using exclusive engineering where an engineer can take the project from the server and go to the site, and if some modifications are done, whenever he comes back and connect to the server project server, then that project can also be again synchronized with the new whatever updates he have can be mentioned and can be synchronized in the server. And for this exclusive engineering, by default there is no license required. Like in multi-user engineering, a separate license is required, but in case of exclusive engineering, no separate license is required. It is only the project manager or the project server where the TI portal project server has to be configured. Additionally, this two editors, that is CEM and CFC, which we will highlight more uh, after this in the next slides. Then we have the TI portal test suite. Test suite is basically for the testing of the projects, where not only the logic part, but also in the test suite, if mostly the standardization, as you know, the standardization is the backbone of any industry. So for the standardization part, there are some features like naming patterns. So for example, if there are options required from standard, means if to maintain the standardization, if some options are required to check whether the style of the naming, like the first word capital, the middle word capital, and the last word capital, is maintained or not. So those type of things can be checked by using a style guide checker feature, which is there in test suite. And apart from that, there is a program test, which is in test suite, where you can check the program whether the program is written in the correct manner or not. That can also be done. And these all features use openness, which my colleague, basically not test suite, but the openness part, my colleague Pankaj will also show you on that part, on the openness part. All, can you just mute yourself? So TI portal version control interface, as already mentioned, in case of multi-user, we are using some version control. Apart from that, there are other customers who are also using some other version control, which will be more elaborately shown with some demo by Pankaj. It's basically how to maintain the um, programming versions in the server. Then all these things are basically using the TI portal openness, and how openness can help you do the engineering, that will also be shown by Pankaj in this session. And there are some TI add-ins and TI portal cloud. TI portal cloud feature will not highlight now. We will see it later on. And the last day you will also see the WinCC unified. And so this is some new features, and the few of things, or what we call as VOT, will also be shown by my colleague. So this is the total product overview, engineering and runtime options, which is available till version 17. So you can see most of the things are already known to you, but just to highlight on some of the parts, like Civarc within CC Unified is available. So you can see here. Then unified runtime options, Prodiac, all these things. So these are the different runtime options, which is having like Prodiac, because you know in Prodiac you need a runtime license also. Then energy suite, runtime and energy monitor, then OPC UA, WinCC Web UX, Safe Kinematics, Robotic Library, and STEP7 CFC. So today we will also see about CFC, but for doing the programming in CFC, we require a separate license for that. Then there are other parts like PLCsim Advanced, safety, and these are already there. And apart for programming of STEP7 and WinCC, we have this multi-user engineering licenses, and these softwares are basically for the start drive, scout, and other parts. So these are basically the softwares which is required, and you can see here in most of the software versions you are already have the DVD versions or downloadable versions are available. So you can see all the downloadable versions are available, and in some cases only downloadable versions are only available. So nowadays, as downloadable versions are easy to get, so it is mostly preferred. So now coming to the new feature which is there with version 17, and very easy to program, which is called as cause effect matrix, and we call it in a short form as CEM. And by name itself you can understand that this is mostly related to a programming which is dealing with a cause, and what happens with that cause, what will be the effect. So this is plotted in a matrix format, so it will help you to understand or diagnose the problems. So we'll see in more details. So the left hand side you can see the programming structure, how it is, its cause, and this side is effect. And what are the different advantages? You can see here that for writing a cause effect matrix logic, you don't need to have a high level language expertise, because in this case the logic is almost similar like we write with an function block FBDs. So it is easy in that case. Getting the errors, so to retake the errors, so it's very easy because it is the having the matrix structure. And the controllers which are supported in case of this cause effect matrix is both 1200 and 1500. So it gives a solution for both the CPUs. It's not a restricted that only 1500 can be used. And if somebody has already done a program in 1200 and want to change the controller to 1500, and if the program is written in CEM, it will not be a tedious task to change it to 1500 again. And it supports the program dependency. You will see in details about how this program dependency thing will be addressed when we'll see the demo part. And it's basically by default it's an innovative programming language in TIA, and how it is innovative we will see in the demo. So in the next demo, I'll just start the demo here. Just a moment. Hope my screen is visible and the video is playing also clearly.
Yes.
Anybody? Yeah.
Yes.
Okay. So just to start with, it's normally for CEM. It's like as we select the different languages in case of other TI portal languages like ladder, ABD, or function block, STLs. So here also you will have the option of selecting that part. So just to first you have to add a new block. Whenever you add a new block, you can just drop down and select whether which program language you want to select. You can select a CEM and then go for a function block. So once you select a function block, you will get an effect like this. So this side it is basically the cause, and this side it will be the effect part. So normally the process event is called the cause, and the process reaction is called the effect. And you can see here the right side, normally we will write all the causes, and whatever the effect will be on the top side. So think of like a baggage handling system which is having different inputs, and we will just check how this operates here, uh, and we will write the logic in that manner. So if we see here the different logic part, we can think of like the it will have bags being placed in the conveyor for the one sensor, and one can be the weight of the luggages should not be more than 20 kgs, so the weight should be measured. And what is the destination of the bag? So depending upon the selected destination, the path, conveyor path, will be selected. So you can see here the different sensors are being mapped, and also the destination. Apart from that, the weight. So now once all the points are defined, now we can go to the cause and we can write. So for example, we will check if the baggages are there on the conveyors or not. So there are two conveyors, and we will name it as get the sensor. So once the first cause is written, so we will check it for the sensor. Then the next part will be to check about the weight. Okay. Another part is like whether the bag is there on the conveyor for a long time or not. So for that we can add a delay, and to add a delay you have already seen, like just I'll little bit go back. uh, so just you can go and check it from the basic functions and drag and drop it and add it to the block itself. So it is not like a difficult task only adding a delay. You can just write the timer's value, and automatically the delay will check whether the sensor was there for 10 seconds or not. So once the sensor checks the material, then the next part will be checking of the weight. And for that we are using a comparator block here, and in this comparator block we will check whether the weight of the bag is within 20 kilos or not. So the comparison is done, and we'll name it as the get the scale, means whether weight of the sensor. Now the next part is to see what is the route of that particular package. So whether it is in going to Hamburg or it is going to Munich, we can select the particular section, and it will check for that particular destination, and this will be the cause for that. Now what is the effect regarding all these causes that we have written? What is the effect? The effect is like whether the bag will go run to the conveyor which is for Hamburg or it is for Munich. So depending upon the selection, the sensors, the weighing of the material, and the input, whether it is going for Hamburg or Munich, the effects will work. Okay, so now both the outputs are now, means outputs are connected to the effect. Now we have to connect the matrix. So individually, what all things logic will be connected to individual outputs. So the first will be connected to both. So we can take a endpoint here and we can define. So in this case, we have 3 out of 3 connectivity. So different connectivities can be defined in this cause effect matrix. So I'll just make it a little bit fast. Yeah. So if you once select here, you can select an action point, and then you can select how many action groups will be there. So here we require 3. So we will select individually all the 3 points. So first is sensor, then bed and Munich, and in the second for the second one, which is for Hamburg, and the second one is for Munich, where we will select this 2 and the last one. So 3 out of 3, and we select it, and all these things are connected. So this is the first part of the logic. But now, say for example, if some security or uh, there is a checking to be done, and they want to stop the conveyor to check the particular luggage. So we require a particular input, say a push button. So from the security part, they will come and push the button, and automatically the conveyor should stop. So for this we will take an input here for checking, and we name it as red button because it is stopping the luggage. So luggage check, and once we press this button, that both conveyor should stop. And another part is basically to reset this, because once the checking is done, then again the conveyor should be in the running option. And for this we will select two indicators. So one indicator will be a constant red, another can be means basically the stopping the output, and another is basically the red blinking. So I can add another input to this particular effect part. So to add, just we have to click on that output C, and we can again add it. So this is basically the output for the blinking part. Now just to add on, because here we will also check this input. So all these three, and this one should be not, the input red button should be not. So if it is not, then only that particular cause will have an effect. So for that reason we have taken a not. And also here, just I'll pause it once. To make it, we have set, we have taken not n, we have taken a set point here. Just whenever the push button comes, this output will be set, so the red will be continuously blinking, and this output will stop the conveyors from working. So once it is done, on all the selection, means the process is done, then the another part we have to do is resetting of this um, particular output. So for that we just need to press the reset button here, and once the reset button is placed, and we have to connect this reset in this matrix, and the output will be resetted. So now we will just go online with the system to check how it is operating, and for that we have to just check and go online. So we are going online with the PLC, and at this moment, say for this, depending upon the selection, the conveyor is working in the place of Munich, or if it is selected as Hamburg, it will go to Hamburg. So all these things are true, and the output is also coming. And in the meantime, if there is a set button pressed, means red button for checking, then you can see here these two conveyors have stopped now, and the output, that red blinking or the stoppage of the conveyor, is being pressed now, and it is stopped, and this output is highlighted. So once the checking is done, we can just press the reset button again, and once the reset button is pressed, the process will again start depending upon the selection. So this is just an example how the cause effect, and that's a simple one. So you can make some different critical applications depending upon the requirements. And you can see by, as because it's like a graphical interface, and it's like a matrix, we can just by seeing in the picture or the chart, we can directly access which what is the effect and why there is a problem in the system. So this was the first part, which is basically the CEM. Now the next part is basically the continuous function chart, or CFC. So with version 17 we also have this CFC, and this gives us a flexibility in doing programming in different processes and how it is. So with step 7 we have this CFC option, uh, and you can see it as because this is like a chart view or a graphical view. So solve of automation tasks already in the configuration phase. So you can imagine like different general automation programs, like in a drawing as a technical chart. So it's like a technological chart here, and we can identify the different sections itself. So and then parameterizing also for the technology functions, like for example normal, whether it is an AND or it is a PID controller, or any closed loop control. Using these functions we can create it with much more faster, because while programming in a chart system, it is easy, like a drag and drop and connect the different inputs and outputs, connecting the different charts also, like dragging the outputs to another chart input is easier. So if already people who are have worked with our S7400 or PCS7 system with CFC, then it will be easier for them also to understand and work on this CFC part. So I'll not go more details in this part. I think the demo will help you out to visualize on that part. So this is a video basically, because I don't have the CFC license with me. I'll just share my audio, system audio.
Adding a CFC chart.
Hope the audio is also clear for all. Can anybody confirm?
Yes, yes. Yes.
This can be done by selecting Add New Chart. To add logic, open it and use functions from the instruction window on the right side. CFC offers a wide range of system functions which are well known from other programming languages. Just drag and drop the selected function to the chart and connect the blocks with each other. One chart can contain several partitions, each of them having up to 6 pages, where you can store your logic in. Let me quickly show you how easy it is to connect blocks from different charts or partitions with each other in CFC. To open the same chart in a second window, select the suitable symbol and then use the TIA portal option to split the editor space vertically to see both charts next to each other. In the next step, navigate in both windows to the desired partition and block, and then you can set the connection between the blocks. This is just as easy as it gets. Connecting two different charts with each other works the same way. Programming the code is one important part, but following and reading the code is another. Following signals is easy as pie. In my example, I have already set a connection from a block in chart 1 to a block in chart 2. Double-click the output signal, and as a result, the system opens the chart 2 and jumps to the correct position. In CFC, the run sequence is displayed on top of every block. To activate this view, click on the corresponding icon. To edit the position, change to the control flow and then drag and drop the block to the requested position. Beside of that, every maintainable program requires proper comments and notes. For this, CFC version 17 offers large comment boxes that can be customized. Furthermore, you can even add pictures in those comment boxes to visualize the process. This supports an effective implementation and maintenance for the engineering and operation staff. Structuring the program is also highly important. For this, CFC offers the usage of groups for the charts. Another way to structure and reuse already existing charts within CFC is the feature of chart in chart. Let me quickly demonstrate this. We take a chart and add some logic you want to reuse, and connect signals to inputs and outputs of the block interface. Then open another CFC chart and drag and drop the chart with the reusable logic into it 2 times. As you can see, the result are 2 blocks that can now be connected with different inputs. My block in this example will divide the input by 2 and negate the result. To improve the traceability of the programmed logic code, you can jump directly into the block by a simple double-click. This helps to identify problems that are located within the created chart in chart block. Now let us continue with 2 of my favorite features. The first one is that you can use individual created logic blocks within the CFC. This saves a ton of time by using already existing knowledge. Let me show you how to do this. I have already prepared the block, My Complex Alarm, that is already compiled. The function block contains an instance of the program alarm in the static memory area. Now we can drag and drop the block to the CFC chart. Finished. Of course, after improving the logic of the block, an update is possible. For this, we add an extra input and compile it. To conclude, go to the chart sequence and extras and navigate to the block types. There, you have the option to execute an update. As a result, the new input is added. The second feature is that you can configure alarm messages directly at the block instance in the CFC chart. For this, you must add a program alarm instance to your function block. This is already done in the function block we have added before. In the CFC chart, select the properties of the block and change the text of the alarm message. That is super easy, isn't it? As we have completed the user program, I will show you how the CFC looks like when you go online on the controller. The initial download requires a complete software download that includes a PLC stub. Smaller changes can be downloaded while the PLC is still in run. I have already executed the initial download. I just have to go online. CFC offers the option to select specific values that should be observed. This avoids unintended increases of communication load on the controller. In the testing phase, however, it is more important to observe all values. To solve this issue, CFC connectors can handle a multi-select. To change several connectors at the same time, go to the control flow and select all required connectors. The testing phase is not limited to only observing values. By setting the option to force values, the user can even force inputs to blocks that have a connection. But note, the activation of forcing requires a software delta download. I will show you this in the simple example of a block that is used for a double integer division. Just type in a new value and look at the output of the div block. The dividend IN1 is not connected, and as you can see, only a simple forcing is activated. The divisor IN2 is connected to a fixed dB signal with the value of 1, as you can see on the block terminal. The connection to this global dB signal that is located in the normal user program shows that CFC gives the user the possibility to interact with other program languages, especially Graph S7. To force the connected input of IN2, you have to select the properties of the input and change the force value. This is nice as you do not have to remove the connection of the input. In addition to that, CFC has a built-in trace for a first analysis of signals. To use the feature, add a new trend display and open it. Then drag and drop the signal from the CFC to the trend view. The result is that you have a trend of the signal right away. Of course, a connection from CFC blocks to the HMI and to OPCUA is possible too.
So, just a moment. Yeah. So this is basically the demo on the CFC part, and you can see already if people in this forum have already worked with CFC, then you already have an idea how CFC you can do the programming in CFC. And not only the normal programming features that were there in CFC, apart from that some add-on features like what we get as a flexibility in TIA, like you've seen, like dragging the input directly to the interfaces, the system is getting connected. All these features are also there. So hopefully if you are using CFC in your project, then it will be a good advantage uh, for you to work on that this part. And this type of videos can also help you out to how to do the work on that. And apart from this, we also have separate manuals available to how to do programming on CFC with CI portal. All these things are also available. So now for the next part, which is basically how this programming, whatever you are doing, whether it is in CFC, whether it is in CEM or ladder, FBD, any type of programming, STL, any type of programming languages, these are basically to make your standard programs. But to use these programs in repeatedly as a OEM or a machine builder, what we do is we need to change some of the part, some hardware part or some software part, but my exact libraries related to these machine will be same. Only thing, some parts will be added or deleted in the program. And for that, how you can use the hardware by simple click or your blocks in a simple click, it will be shown by my colleague Pankaj. So over to you, Pankaj.
Yeah. Thank you, Prasanjit, for the nice explanation in setting up the phone. Just let me know once my screen is visible.
Yes.
Okay, yeah. Thank you. Hello all. So, as told by Prasanjit, so in this section, we will see the openness AI portal openness. So, what exactly openness and yeah, and what is this openness and how it will work? So, in this, we will see now. So, basically, to develop this openness application or work on this openness, basically, we need this know-how or knowledge of this TI portal version. TI portal and this higher programming language like the .NET, the C Sharp, like this. So basically, by using this openness, user can create this across. User can use this feature application across the many devices with application specific changes. And by defining some base templates like UI interface or like this, you can allow this user to generate the entire project, like creating the project, importing the blocks without any knowledge of the PLC and HMI programming. So here you can see in the first section, user needs to or engineer needs to go in the TI portal and do like creating the project and create the blocks, export and imports. But by using the TI openness in the downside, you can see by using this Visual Studio tool and higher level languages like as explained C Sharp, you can develop your own TI portal UI, openness UI, you can say. And by here itself you can create the open the project, open the TI portal, open the project and compile the project by using this DLL library. So your user or engineer don't need to go in the TI portal. From the UI, from the openness application itself, he can create the project and he can import or export the blocks or HMI screens like. So here are some functionalities of the openness. By using this openness, we can create the project data, delete the project data, modify the project data. And this openness basically, whatever the blocks we are importing or exporting, this block will be generated or exported in the XML format. XML format it will be export. This format you can also open by using this Notepad plus plus tool or any Visual Studio tool, and there also you can see the code and make a changes accordingly. Yeah, so this is the UI. From UI also you can make changes. Yeah, this is on the .exe file. This is the whatever you application create the application openness application, which will be in the .exe file. This is the flow of the here openness. Basically, how we can generate the hardware configuration and as well as the program blocks or any HMI related PLC tags, HMI screens, etc. So here you can see this is the TI selection tool. By using this TI selection tool, we can generate this hardware configuration, and this hardware configuration will be in the .aml file. So here you can see there are the two procedures. One is we can by using this ECAD can we can import this in the TI portal, and once we import the TI portal, so whatever we have library blocks, we have already defined blocks, program blocks that we can import in the form of XML by using some openness application like TI openness scripter, TI openness demo. In the later demo, we will see how basically it works. So basically, these are the two steps by using the ECAD, and this is the normal procedure. We can import the hardware configuration as well as the program blocks or any PLC tacticals, etc. So just I will go to the demo part. Here you can see the demo. So here I am using this TI selection tool. So here you can see I'm just opening the TI selection tool, and the project I am using. I have created one test project for the demo. You can see. So this is my project PLC1. Yeah, and just go to this configure. Yeah, and here in the configure, you can see the PLC. Yeah, yeah, just goes to this configuration. Yeah, here you can see we have already set up the hardware like a PLC and AI rows and DI. All the hardware configurations are done. Now that configuration I want to export it into the import it into the TI portal. So how we will do? So here we can see in the TI project, so in the TI selection tool project, there are a lot of options here. The save the project, whatever we have done this configuration, there is options for save. And here one option is for import. So whatever we have already hardware configuration, so that is also possible to import in the TI portal. And by using this import, and once you import, if you want to add some devices or to make a changes in the hardware configuration, that is also possible by using this tool. And also export. So export. So here export is possible in the TI portal or also ECAD system. So this export file will be generated is the .aml file. So now we are exporting just those whatever we have made the configuration. So here you will get the option TI portal. Here are options like you can use this TI version 16, then TI 15 or folder one, and you can also export in the ECAD. So now we are exporting this hardware configuration. Yeah. Once we export this hardware configuration, you can see here this file will generate it in the format of .aml file. So now we will go to this our TI portal project. So in the here in the tools, you can see the various options like export the project text, export the CX data, import the CX data. So import the CX data, nothing but we will importing this hardware configuration here. Yeah, here. So we are just importing this AML file in the TI portal. Yeah, now import is successfully done. So now here you can see my PLC, that is CPU 1511. Yeah, and all the hardware configuration, as I said, we have done is 8200 SPs, the IOs related, all the configuration is successfully imported. Yeah, so by using this openness, by using this TI selection tool, we can configure we can import the hardware configuration And now this part is done. So now if we want to import or export the whatever we develop the project, and we want to export it, we have to use the different machine. So like we have the different program blocks, HMI screens, and the PLC tag tables, all the other programming part. So that is also possible via openness scripter or via openness demo application. So that part we will see now. So here we are just using, we have one application like a TI portal, openness demo application. So here you can see, you can select the which version you are using, like TI portal version 14, 15, 15.1. So for now we are using the 15.1, and this is the version. So just select OK. So this is the UI of the TI openness demo. Basically, this is developed in the backend by using this higher programming language, and this is the complete openness application. So here we are just selecting the project. We have already one project, XML project. Yeah. Here you can see now you don't need to open the TI portal by using your own the TI portal or TI openness application itself. Open the TI portal, and itself it will open the TI project also. So so we don't need to go in that, select the TI portal and open the TI portal. By using this application itself, we can open. So here you can see in the TI openness demo application, all the project backup, all the whatever the in the project, you can see here PLC, HMI, all part. Yeah, program blocks like main. I have this configuration in this program like the motor one, motor two. These have the some different program blocks. And at the bottom side you can see the debugging point. So all the whatever you are opening the project, you can see in the bottom side. Yeah. So now here the different EMs. So now just in the upper side you can see there is a buttons like export, import, compare the project, compare the save, and save the project. So from here itself you can save the project. So now just I am exporting this block. Basically here, what are the program blocks we have? Just I am exporting this block. And yeah, so I have exported block. So here you can see this is the time start the export, and export is successfully done. All the debug or error message or whatever you can see in the bottom side. Yeah, and here the setting of this, here we can do the setting of the TI portal, TI openness application. Like we can define the path where we want to export this file. Basically, so this path is defined here, and also there are the user interface, other settings are available here. So now you can see here, these are my exported program blocks. So these files are generated in the XML format. So till now here we can see we have successfully export the project backup like program blocks and all this XML files. So now suppose we want to import also. So from here also it is possible to import, and we have also one application, we called it the openness scripter application. So basically what it will do, it has the function like starting the same. This is also developed in this openness application, openness itself. Like from here we can select the PLC, selecting the HMI, importing this XML here, XML files here also possible. So for the importing we are using this application. Here you can see this is the command line program in the backend. There's complete higher programming language is running, but user needs to only like commands like open the portal, open the project, select the PLCs. Here just use, here we have to define this commands only, like import the program blocks, and we have to define the path, and it also compile the TI port. So here my TI portal is opening now. You can see the steps also in the green mark, which line or which command line is running. Yeah, select the PLC. So program blocks, you can see now it's creating the program block folder EM. You can also create the folder also by using this command here itself. So here you can see one folder is generated. So we have created this program block folder called as EM. So you can see here importing the data, all the data one by one line is running. Yeah, and it's compiling the configuration, whatever we have imported, program blocks, all this it will compile. And you can see here in the bottom side all the successful messages, all the information, or here you can see all the debugging operations. Like all program blocks are successfully imported and compiled. So these are this openness application. Basically, by using this openness, we can export the block, we can import the blocks, and there are others suppose we have like 2 3 conveyors are there. Just I'm giving this example, like we have the 2 conveyor belts, and user needs to add one conveyor belt. So just they want to do this replica for other machines. So this is also possible by using this openness application. This is for done for the openness. So now we will go to this version control interface, that is nothing but the VCI. So in the current situation, now everyone is working from home. So now suppose we are working, suppose there are 2 3 engineers are working in the same project, and they are working their home, or someone is office, someone working from the site, or someone is working the office the same project. So and every engineer need to update on the same project. So for this we need to save the project in the central location, so that every engineer or each engineer can update on this project, and everyone can get easily access and know the latest update of this program project. So to do this VCI, we are using this version control interface. So here you can see these are the flow, or we can say the structure of this. Like this is the version control interface. By using this VCI, we can export the data or import the complete project, like program blocks, user data, tag tables, to the GitHub. So here we in this demo we are using the GitHub basically as a third-party repository system to store the data centrally. Yeah, and we can also store it in the local machine, so that we will see it in the demo. So all this file will be generated in the XML or SCM. So this is the demo for the version control interface. So this is my own project, and here you can see there are the main blocks, FC and FB. So here in the configuration in the bottom side, you can see the version control interface. So we have just go to this version control interface and just add the new workspace. This workspace nothing but it will store the data. It will store the whatever you have project backup it into that workspace. So now here you can see this is my window for the workspace. Here all the whatever your program blocks and tag tables it will generate. It will show here PLC tag tables if you have the PLC tags, and then program block. And here you can see in the import options, export option, and synchronization options. So this is my completely VCI window. And here in the right side you can see workspace, means whatever we have the data, this project backup that we want to store it in the particular local machine, and then and also the GitHub centrally. So this is the workspace. So we have to configure this workspace basically. So we have to define the path where we want to store the data, or where we want to save the project backup. So just I have selected this workspace, and for now we are not there is no git options for now in this. We are just storing the data or storing the project it in the local repository, local machine. Yeah, here you can see. So now we are just click on the PLC1 and just sync it and just export it. So it will go with these options, and then we have to hit this. So here you can see this is export is successfully complete. So here you can see there are the status bar like a green. That means it is successfully exported to my local repository. Yeah. And here you can see the PLC1 folder is coming in the my local repository. Once I open this, you can see all the PLC blocks and program blocks are generated here. And that also we can see it in the folder. So this is my local repository. Here you can see, and all the files will be generated in the .xml file. So now in this, basically we save the data, save the project backup to the local repository. So, but what if my engineer is working on the site and he wants the access of this project also, and he wants this project backup, and he also want to develop this some points. And so what? So basically we have this, as I said, we have the Git third party software where we can store the data, all the project to the GitHub. So in the our CEOs interest or our support system, we have this TI portal add-ins. So basically, just we have to install this TI portal add-in, and in the path where your automation, basically where the TI portal is there, just you have to add this add-in it in the path, git add-in basically. Once you add this add-in, so here in the right side you can see the option about the add-in. So you will see this window like HTML, this TI portal add-in, git add-in. So just you have to activate this add-in. Now you can see the status is not there, just we have to activate this. Once it activate, it will show the green mark. So now my TI add-in is git add-in is activated. So I am giving the path for the TI Git version. So just go to this configuration and just add the Git. So I added the Git here, version control adding Git. So by using this Git option, we can export all the project to the GitHub directly. So here you can see for the demo purpose, I have this GitHub account. I have created one repository which is called as the VCI. You can also create new repositories. If you are using the new project, then you can also create this repository VCI. Yeah, so I have created already repository, and I have already the exported the P1 program block here. You can see. So now I have made some changes in the program block. So here you can see I have added the network 2 in the FC. You find the tag. Yeah. So here you can see now my project status will be gone from the green to blue. So this is not synchronization with my GitHub. Likewise, you can compare the both, whether your current application is synchronized with the Git. So now my second engineer wants to see whatever the latest update. He want to see the data. So we are just exporting this FC to the GitHub. So now here also you will get this option, import or export option, and in the upper side also you will get this export all option. By using export all, you can export all the PLC blocks. So this is compiling. It will automatically compile the program. Now synchronization is complete. Yeah, once the synchronization is complete, you can see the green status. That is completely synchronized. Yes. So here you can see now when we now we have already added the git add in. So here you can see now the git pop-up is coming here. By using this git, we can push the code. We can commit this code. Here you can see we can add the code. Then we can push the code, and we can also pull. It is possible to pull the code from the GitHub. Means my second engineer want to pull the data, whatever the latest comment we have. Just if you want to pull this all the, or if you want to import the project, then by using this option, he can pull this data, all the project in the his project repository. Yeah, so these are the different options. So now I made the changes. I have added the network in my FC block. So just I am giving the commit here. Commit is nothing but the comment or whatever you made the changes in the program, so that other engineers can easily know the latest changes. Now I added the network 2 in the FC block. So just I will put the commit here. So now you can see this is my commit is successful. And now once the commit is successful, I just want to push this backup or the project it in the GitHub. Basically, this will execute the git command. We don't need to go in the GitHub or any other open the command prompt or any other. By using TI open TI portal itself handles this git functionality. So here you can see my git whatever the project is successfully exported to this repository called as the VCI. So just we will go to this GitHub account. I have already exported this PLC block, PLC all the blocks, and now I will just refresh it. Yeah, and you can see here, this is my latest commit. Like I have added the network 2 in this FC block. So like you can see, this is 1 minute ago. Likewise, the other engineers will be know that the latest update or latest code, so that he can also import the same project code version. Yeah, here you can see different commits are there. Added network tools in the FC block. So this is my latest commit here. So likewise, here you can see also I have added. So here you will see. So my different. So other engineers is working, and he also same. He also did the same thing. He also push all this code to this all the project backup to this GitHub. So that here his name will come here. Like so, everyone knows that who made changes in the program and who which latest push. Yeah. So that all the engineers will be updated with the same project. Yeah, so this is from the my side VCI and the openness version control and the openness part. So now suppose we are developing this program, we are doing this programming engineering in the TI portal, and we want to test this application in the PLCsim advanced. So we have everyone knows that we have the PLCsim advanced, but there are the new features are there. So that will be explained by the Prasunjit. Over to you, Prasunjit.
Thank you, Pankaj, for a great demonstration and good demos shown by you. And I think after this demo, you can understand that how openness is helping to build the project from your library projects and your already added hardware configuration, standard hardware configuration, directly into a blank project and making a new project out of it. Then already mentioned earlier also, by using multi-user and project server you can maintain version control in with the help of TIA. But as because of this work from home nowadays and this pandemic situations, every day now we require that okay, somebody is working on one part and he keeps a updated backup in version control and use it in another. So version control will help in accessing the programs and maintaining the versions and use it directly in the logic. But once the logic is made, the next step is to simulate it as per the real hardware behavior. And as every time we say that already PLCsim Advanced is basically we it's like a digital twin of our PLC, and this will help us to test all the different scenarios sitting in your home office or anywhere without the real hardware in your hand. So just today we will be mostly highlighting on what part are basically the new features. So we'll not go in details of PLCsim Advanced, but the new features, like one of the new features, as you know already, that because of the 1500 new CPUs are added also in the with TI version 17, as I already mentioned. But one feature was not there at previously with version 16 until version 3.0 of PLCsim Advanced, that 1500 and H were not supported. So checking the logic with PLCsim Advanced was not possible. But now with version 4.0, it's possible to check the 1500R CPUs, whether it is 1513R or 1515R, and also the 1508 CPUs, which is 1517H or 1518HF. So all the different CPUs can be used because this is now added in the API of PLCsim Advanced, and you can see all the different CPU type, primary, run, solo, and everything can be checked. But only thing is here it's like not the redundant mode. You cannot check the redundancy with PLCsim Advanced now till the release version, but you can check it as a working as like a run solo mode. So the PLC program can be checked with PLCsim Advanced, but not the synchronization behavior of the two primary and backup CPUs. So in with the new version of PLCsim Advanced 4.0, you can see here there is a drop down, and in this drop down you will find all the different variants from 1500, 1500 RNH and other different CPUs. So here we are talking about 1500 RNH. So you can directly select 1500 RNH and download the program and test it in the PLCsim Advanced scenario. The next part is, as you know, nowadays people are also looking for CPUs which can be mounted directly on the shop floor without any panels, which is having IP65 or IP67 grade already. So in that case, we in our portfolio, we have Matic 8200 Pro CPUs, and for that with PLCsim version 4.0, we also have this 8200 Pro CPU supported, and all the different variants of Pro CPUs, like whether it is the standard 1513 or 1516, or the safety 1516. uh, so all these CPUs can be checked directly in our PLSIM Advance, because this is also the same way like you have seen in 1500 RNH, the APIs are now added in 1500 PLCSIM Advance. Another feature is like for semantic drive controls, where you have the different support of simulating the T CPUs, like CPU 1540TF or 507D CPUs. So with the onboard IO controls, it can be simulated, but it is not that you can simulate the integrated S120 part, but only the TCPU part can be simulated. Then there is another feature directly in the API. If you open it and in the user interface you will see there is a new selection available, which is the strict motion control. And this strict motion control is helpful when we are using a motion control function in S7 1500 or S7 1500 TCPUs. And if we enable these functions, you can see that once we enable the selected, like the MC servo clock is synchronized with the PLC cycle, and this ensures that the correction of calculation of analog hardware PLC. So, and it also includes the original messaging behavior and the diagnostic buffers. So this is another feature with PLCsim version 4.0. Then with PLCsim version 4.0, we also have the secured OPC UA communication. So because nowadays we are always talking about the security part, so open user, and for checking that part we also need to have a flexibility to check in a virtual world. So for that, in version 4.0 we also have the flexibility of checking the OPC UA, the web server, like HTTPS simulation can also be done, and open user communication like secured with TCP communications like tsend and treceive and secure tcon blocks can also be simulated. So as in the last slide of PLCsim Advanced, you have seen that there was a security issue. So now, because of this cyber security part, security is now becoming the most important part for each and every industry. And all the end customers are asking how secure is the communication protocol in your system, because most of the time these communications can be connected to open internet or any other part also, because it is connected in the office LAN or something like that. So how can you protect the PLC, because it may affect the program. If something is affected, then the full system will be stopped. So now we will see this secure semantic PG HMI communication, how we can do it. So if we see here, the first thing is the we come to our always means in all the rest of the PPTs you will find one word which is called TLS, which is basically the transport layer security, because it is the security in the transport layer while transporting the program to HMI, PLC or HMI, or connecting the PLC to HMI. How we can have a security here. So this transport layer security protection of communication between S7 controller and engineering station with TI, we will see it, and it's totally encrypted by applying this individual certificate. So once you will see in the later slides also that how when we are downloading a program, we have to just accept the certificates and then only we can work on that part. So how is it? So this is a true encryption between whether it is a engineering station or a operating station and connecting with the PLC, and it prevents all the different manipulation of the controller program, or if you also the parameters, because if some parameters are changed or some manipulations are done without any security, then it may affect the total process. So I'll just go a little bit details on this part so that will help you to understand. uh, just a moment. Yes. So with this TI version 17, several security improvements for the communication between engineering station or a PLC station and HMI panels have been introduced. So mainly, the first part is communication. The communication is secured by means of transport layer security, TLS protocol, means transport layer security protocol, or TLS, widely used in the internet. It provides encryption and data integrity between the communication partners. Next is the communication is encrypted by applying individual certificates for each partner. The certificates can be imported or created in TI portal with semantic managers. Next is to ensure the semantic controllers works with older configuration, compatibility mode can be activated to support secure and legacy mode communication with older devices. Then the encrypted communications provides additional protection against unauthorized access to the devices. It also protects against data manipulation and ensures data integrity. Additionally, the configuration that can be protected by user defined password. This protection is optional. So, what are the benefits out of it? The unique and individual certificates and password assignments increases the security of the devices, as not all of them are exposed in case of security breach or one devices. The password protection ensures that the PLC configuration only changes by authorized users. So these are the list of components that supports the new security semantic PG communication can be, and this is all you can see here, mostly like all the different variants from for 1500 all to 2.9, from version 2.9 onwards, 1200, 4.5, PLCsim Advance, drive controller V2.9, and the clients like STEP7, HMI, uh, basic panels, mobile panels, comfort panels, unified panels. All these are supported with this. Means this is compatible. So now let's have a look at the mechanism for improved security for PG HMI communication. So when there is no configuration available on the semantic controller, the PLC has a self-signed device certificate. Now, when we start the download from TI portal, the semantic controller sends the device certificate to TI portal. And the certificate is unknown to TI portal because it is newly created. So the user needs to manually accept it. Then the download of the project data and the configured certificate starts. From now on, the certificate is available on the semantic controller and known to the TI portal. So after the initial download, the PG and the semantic controller can perform TLS encrypted communication. Each semantic controller has its own certificate that is trusted by the communication partners, whether it is a PG or a HMI. So how and PLC is the same in TI portal. So in a TI portal project, the certificate trust is handled automatically during the configuration. However, the certificate trust on HMI depends on the way of configuration. If the PLC and HMI are configured in the same project, the user does not have much to attend to. The certificate is downloaded together with the HMI configuration. If the semantic controller and HMI are not in the same project, the certificate must be exported from the controller project and imported into the TI portal project alongside the HMI configuration. Then it will be downloaded to the HMI together with the configuration data. If now the HMI is configured with another software, then TI portal, it is possible to export the certificate from TI portal and manually import them on the HMI. This must be done once only. So next is, now let's have a look at the protection of sensitive configuration data on TI portal version 17. So to protect the confidential configuration data, the user has the option to enter a password in the TI portal. The password is downloaded with the first download together with the confidential and non-confidential configurations data. The password is saved directly on the semantic controller and encrypts the confidential configuration data on the semantic memory card. Now, typical configuration data considered as confidentials are certificates and private keys. The non-confidential configuration data is stored on the semantic memory card together with the confidential data. And with this new mechanism, the user has the option to protect the sensible configuration data with a personalized key. So now it is important to keep in mind that this settings has an impact on the device exchange scenarios. So there are three different possibilities to exchange on old controllers with a new one. So the first one, either by downloading the project directly on the new controller, the password as well as the certificate will be set on the new controller during the first download. Now, for the second one, by direct online access to new controller to set the password. Now, after that, the memory card from the old controller can be used on the new one. And for the third one, option is to use an additional semantic memory card. The password as well as the special job files are stored on this memory card, which can be then inserted into the new controller for initial configuration. After that, the memory card from the old controller can be used on the new one. So with TI Portal version 17, several options have been pre-configured and set by default to ensure a high security level for machines and plants. And this includes pre-activated PLC access protections that prevents any type of access to controller unless explicitly configured. Can you please mute me? The pre-activated configuration password requirements that ensures all configured data are provided by default. Then the next point is the predicted secure PG HMI communication, which prevents unsecured communication with other partners. Only when the mixed mode is explicitly allowed is the unsecure communication possible. So for the configuration in TI Portal version 17, the user user is guided through a secured wizard which assists them with the security settings. This includes the protection of confidential configuration data, the access level of semantic controller, and the secure PG HMI communication. So now the newly introduced secure features are only active on TI Portal version 17 products and relevant configuration, and this is done by this selection of the checkbox. So new firmware but bold configuration data will work in compatibility mode as configured. So communication to TI portal and HMI system with older version 17 is still possible. So now the coming to the last part of this security, the semantic controllers on TI portal version 17 can work in two modes, secure mode and mixed mode. In the secure mode, only TLS based secure communication is allowed between the controller and engineering station or HMI panels. And in the mix mode, in addition to the secure communication, the legacy mode can be used. This allows communication to engineering station or HMI panels uh, that use older version of TI portal. The communication between semantic controllers in TI portal version 17 and engineering station or HMI panels that use older version on TI portal is only possible in the mix mode. By default, only TLS secured communication is allowed on TI portal version 17. However, these options can be deactivated if needed in case such as when the performance is affected due to higher security standards. So, too many theoretical things, which is much important nowadays because of this security things, and uploading and downloading restrictions can be made.